Good morning, students. In the last lecture, we discussed what is meant by conductors and insulators along with semiconductors. We also briefed about what is meant by electron theory and the conventional electron flow that is there in our textbook. Now, in this lecture, we are going to discuss the different units that are used in the electrical systems such as amperes, volts, resistance, and watts. Amperes. The ampere is the unit used to measure current flow. When 6.28 billion electrons, also known as coulomb, move past a certain point in 1 second, this represents 1 ampere of current. The ampere is the electrical unit for the amount of electron flow, similar to how gallons per minute is used to measure water flow. The unit is named after the French electrician Henri Marie Ampere, who was there from 1775 to 1836. As shown in figure 15, 1 ampere is the movement of 1 coulomb, that is 6.28 billion electrons past a point in 1 second. Now, conventional abbreviations and measurement for amperes. Here are the conventional abbreviations and measurements for amperes. The ampere is the unit of measurement for the amount of current flow. Acceptable abbreviations for ampere are capital A and amps. The capital letter I for intensity is used in mathematical calculations to represent ampere. Amperes are measured by an ammeter, not ammeter. As depicted in figure 16, an ammeter is installed in the path of electrons similar to a water meter, which measures water flow in gallons per minute. The ammeter displays current flow in amperes. Volts. The volts is the unit of measurement for electrical pressure and is named after Alessandro Volta. He was from 1745 to 1827. He was an Italian physicist. Using water as an analogy, it is comparable to pounds per square inch, that is psi. It is possible to have very high pressure, that is volts, and low water flow, that is amperes, or high water flow, that is amperes, and low pressure, that is volts. Voltage is also called electrical potential because if there is a voltage present in a conductor, there is a potential or the possibility for current flow. Voltage does not flow through conductors but causes current, that is in amperes, to flow through them. As illustrated in figure 17, voltage is the electrical pressure that causes electrons to flow through a conductor. Conventional abbreviations and measurement for voltage. Here are the conventional abbreviations and measurement for voltage. Volt is the unit of measurement for both the amount of electrical pressure. Another term of voltage is electromotive force, that is EMF. The letter capital V is the generally accepted abbreviation for volts. The symbol used in the calculation is capital E, representing electromotive force. Volts are measured with a voltmeter. Figure 18 shows a digital multimeter set to read DC volts being used to test the voltage of a vehicle battery. Most multimeters can also measure resistance in ohms and current flow in amperes. ohms. Resistance to the flow of current through a conductor is measured in units called ohms, named after the German physicist George Simon Ohm. He was there from 1787 to 1854. The resistance to the flow of free electrons through a conductor results from the countless collisions the electrons cause within the atoms of the conductor. As shown in figure 19, resistance to the flow of electrons through a conductor is measured in ohms. Conventional abbreviations and measurement for resistance. Here are the conventional abbreviations and measurement for resistance. The ohm is the unit of measurement for electrical resistance. The symbol for ohms is omega. It is a Greek letter, the last letter of the Greek alphabet. The symbol used in calculation is capital R for resistance. Ohms are measured with an ohm meter. Now watts. The symbol for power is capital P. Electrical power is calculated as ampere times volts. Power, capital P, is equal to current I multiplied by voltage, capital E. A watt is the electrical unit for power or the capacity to do work and is named after the Scottish inventor James Watt. He was from 1736 to 1819. Figure 20 shows a display at the Henry Ford Museum in Dearborn, Michigan, which includes a hand crank generator and a series of light bulbs. This figure shows a young man who is producing electricity with help of cranking the hand crank